This lesson is on how to graph a sine function. So we're going to start by looking at how to graph y equals just our basic sine x. So if you were going to graph this using a t-chart, you would want to use our main key points around the unit circle. So on your unit circle, we know we start at 0 radians. Then we go to pi over 2 radians, pi radians, 3 pi over 2. So those would be our key points because those are going to give us values of 1, -1, or sorry, if we're dealing with sine, 0, 1, 0, -1. But that's going to change a little bit for this function because we have this b value here. So remember, this b value changes the period of our function. So we're going to have to keep that in mind. And this value right here gives us our amplitude. So for our t-chart, what we need to do is figure out our values of x for this particular function that are going to give us these main quadrant points. So if we take this 3/4 and set it equal to these main quadrant values, 3/4 x equals 0, 3/4 x equals pi over 2, 3/4 x equals pi, 3/4 x equals 3 pi over 2, and we use that to determine our input coordinates, it'll make graphing this a lot easier. I know normally when we use t-charts, we just kind of arbitrarily decide on values of x, plug them in, solve for corresponding values of y, and plot our points. But it's not quite as straightforward with sine and cosine graphs. So you want to be pretty intentional about the x coordinates that you plug in. So if I solve for x here, 3/4 x equals 0, we're going to have x equals 0. 3/4 x equals pi over 2, so I'm going to multiply by 4 over 3, which is going to give me x equals 2 pi over 3. Here, I'm going to multiply by 4/3, so that's x equals 4 pi over 3. Here, I'm going to multiply by 4/3 again. Notice I'm multiplying by 4/3 every time. 2 goes into 4 2 times. Actually, let's see, that reduces to 1. That reduces to 2, and that gives us x equals 2 pi. And multiply by 4/3, and that's going to give us 8 pi over 3. So we're going to use these as our values of x while creating our t-chart. So 0, 2 pi over 3, 4 pi over 3, 2 pi, and I'm going to stop there, so it'll give us a pretty decent looking graph. So again, we know our amplitude is -3/2, so the distance from our center line to our max and our center line to our min is going to be 1.5 units. Negatives just telling us that this graph is going to go down before it goes up. And this 3/4 affects our period of our function. How long does it take to complete one cycle? So I'm just going to start plugging in values now using our t-chart method. So we have y equals -3/2 times the sine of 3/4 times 0. Well, 3/4 times 0 is 0. We know that on our unit circle, cosine goes with x and sine goes with y. So we know that the sine of 0 is 0. So that's just going to, whole value, it's going to make that whole value 0. Okay? So now we're going to evaluate 2 pi over 3. So sine of 3/4 times 2 pi over 3. So that reduces, and that gives us sine of pi over 2. Well, we know what sine of pi over 2 is because that's one of our main points on our quadrant. So sine of pi over 2 is 1. 1 times -3/2 is -3/2. So you've seen now why we very intentionally chose these values of x, because we knew that when we plugged them back in, we were going to end up with our main quadrant points, which makes evaluating this a lot easier. Okay, so let's go ahead and plug in 4 pi over 3. So negative 3 halves, sine of 3 fourths, times 4 pi over 3. Those reduce to 1, those reduce to 1, so sine of pi. Well, we know that the sine of pi is 0. I'm going to take a guess at what this next one's going to be. If you guessed 3 halves, you are correct, but let's go ahead and plug it in. So negative 3 halves, sine of 3 fourths times 2 pi. It's going to reduce to 3 pi over 2. Well, the sine of 3 pi over 2 is negative 1. So we have a negative 1 times a negative 3 halves, and that's going to give us positive 3 halves. So let's go ahead and plot some of our points here. So we have a point at 0, 0. Since we have 6 tick marks in between pi, this is going by pi over 6. So this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi. Okay, so I went ahead and filled this in. So this is our point 0, 0. This is our point 2 pi over 3, which when you can tell that this went by increments of pi over 6. So 1 pi over 6, 2, 3, 4 pi over 6 is 2 pi over 3, and that's at negative 3 halves. And then we have 4 pi over 3, so this is pi over 6, 7 pi over 6, 8 pi over 6. 8 pi over 6 reduces to 4 pi over 3, and that's at 0. And then we have 9, 10, 11, 12 pi over 6, which is 2 pi, and that's at 1.5. And then our last, we had 8 pi over 3, which I didn't graph, but I'm going to go ahead and put that on there. Our last point was at 8 pi over 3. So if this is goodness. Let's see, so that was 6 pi over 6, 7, 8, 9, 10, 11, 12 pi over 6, 13, 14, 15, 16 pi over 6, which is 8 pi over 3. So you can see when you graph this, our amplitude is indeed 1.5. That's our distance from our center line to our min, or center line to our max. And our period, if we had calculated that, remember period is equal to 2 pi divided by b. So that's divided by 3 fourths, which multiply by your reciprocal, so 4 thirds. Our period is 8 pi over 3. And you can see that is how long it takes. That's the number of units it takes to complete one cycle, is 8 pi over 3. So we know that we did this correctly.